Hey guys, Mr. Milton here. Today we're going to talk about solving equations. At the end of this video, you should be able to solve equations with variables on both sides of the equation. And you should be able to identify an equation with no solutions and infinitely many solutions and be able to tell the difference between them. Alright, in the last lesson we learned how to solve equations with variables on one side of the equation, or equal sign. What happens when there's a variable on both sides? So, in this example, we have 7 minus 6x equals 5x plus 29. What do we do if we're trying to solve for x? Remember that our strategy was to get the variable by itself. That's what we were going to do. If we could get the variable on the side by itself and the numbers on the other side, then we could solve it. And that doesn't change here. So what I'm going to do is I'm going to move the variables to the same side. I'm going to focus on doing that first. Okay. When I move the variables, I like to think, how can I keep my variable positive and make that move? So I see that variables are on both sides. It's negative 6x on this side and positive 5x on the other. So I'm going to choose to add 6x to both sides. I add 6x to both sides. I have 7 equals 11x plus 29. And now I want to get my variables alone, the 11x on the side alone. So I'm going to subtract 29 from both sides. I'll rewrite that work up here. And when I do that, I got 22, negative 22, equals 11x. To find out what x is all by itself, I'm going to divide by 11, and that will give me x as negative 2. Okay. Alright, and so there we go. Notice how we're basically doing the same thing we did last lesson, except we aren't just moving numbers, we're also moving variables. Okay. Moving variables really in the same way that we move the numbers too, so not a whole lot of difference. Okay, so quick tip, if I'm moving a whole term, let's say I'm moving 5x. Actually, I'll say negative 6x because that's what we just did in this lesson. Okay, if I'm moving a whole term, negative 6x, you add or subtract. Okay. If splitting up a term, okay, so for example, where we split up 11x, right? Then you use multiplication or division. Okay. So when I'm moving the whole variable, the whole term of variables, I add or subtract. If I'm splitting it up, then I do multiplication or division. But you can answer that question for yourself by just asking, alright, what am I trying to do? Okay. Alright, so let's look at some examples here at the bottom. Some practice problems with moving variables on both sides. So this first problem, we have 6x minus 5 equals x plus 11. I'm going to move this x to this side. Remember, I want to think, how can I get my variables to stay positive? Okay, so I subtract x from both sides. It gives me 5x minus 5 on the left equals 15. I want to get rid of this minus 5 now. Okay, that way I get the numbers on the same side. So I'm going to do the inverse operation, which means I'm going to add 5. That gives me 5x equals 20. I'll divide by 5 on each side, and that will give me x equals 4. Okay. Number 2, we have 4 times x minus 6 equals 3 times x plus 1. Okay. I'm going to distribute here. 4x minus 24 equals 3x plus 3. Alright, and so now to keep my x positive, I'm going to move this 3x to the other side instead of moving the 4x. And 4x minus 3x will give me x minus 24 equals 3. And so now I'm going to move the 24 to this side so I can get the variable by itself. I'll do that by adding because there was subtraction. and so x equals 27. I should have written that down here, number 1. Number 3 is a proportion. Remember that we can solve proportions by cross multiplying. A clue here is when you do cross multiply, really important that if you have addition or subtraction, one of those expressions, that you put it in parentheses for yourself, just so you can remember to distribute to both terms and not make a simple mistake. So I'm going to rewrite this here as 6 times x minus 1 will equal 9 times x minus 4. Okay, that's just me cross multiplying, getting rid of the denominators of those. So when I do that, I get 6x minus 6 equals 9x minus 36. Okay, just distributing both of those around. I'll move the x's to the same side, and in this case I'm going to subtract 6x from both sides, because that way my x's stay positive. So I'll have negative 6 equals 3x minus 36. Going to now add 36 to both sides, because that way I keep my x positive and I get the numbers on one side. So now I have 30 equals 3x. I can then divide by 3 on both sides, and then I get x equals 10. Alright, number 4, I want you guys to do and bring into class completed. Okay, that's the way that I can check to make sure that not only did you watch the notes, you paid attention, you can do this topic. Alright, so solving new problems. Let's see how that applies to some application problems, some more real world things. So it says, everything plumbing charges $46 for a service call, in addition to $18.50 per hour for labor. Plumbing Experts, a different company, has no charge for a service call but charges $30 per hour for labor. For what number of hours would both companies cost the same? So we have everything plumbing on one side and Plumbing Experts on the other. We want to know when they equal each other. So let's see what their equations are. Everything plumbing, they said they charge $46 just to come out. And then if they're working on something, they will charge you $18.50 per hour. So I'm going to put H, $18.50H. Because for every hour, we're going to multiply that by $18.50 to see how much they're going to charge us. Now, Plumbing Experts, they say they charge $30 per hour. But there's no other service charges for them. Okay, no service call or anything. So here's the equation that we'll use. Okay, kind of use this to think out our equation. But here's the equation that we would use: 46 plus 1850 H, expert plumbing charges, equals 30H, plumbing experts charges, or everything plumbing, I guess. Anyway, so now, since we have this set up, now it's just an equation that we can solve. And we will try to solve it the same way that we have been. Get the variables on the sides together. And if possible, keep them positive. Okay, and we can do that. Okay, so I'm going to subtract 1850H from both sides. And when I do that, I get, sorry, I ran out of room here, so I'm going to move it up here. 46 equals 1150. H. And so now I can use calculator to say, okay, if 46 equals 1150H, I need to find H by itself. I want to divide both sides by that 1150. So 46 divided by 1150 equals 4. So H equals 4, or 4 hours. After 4 hours, or at 4 hours, hours, then both companies charge the same. Okay, now the second question asks us how much would it cost for that number of hours. Okay, we can find that out just by plugging in or evaluating our equation, or one of our sides of the equation, when h is 4. So I'm just going to say, okay, 30, and now instead of using h, I'm going to use 4. 30 times 4 is 120. Okay, tell me which company you would use if you had a job that was going to take 6 hours. Alright, now let's talk about special cases. I kept that on the bar too long. Remember, tell me which one you would use, which company you would choose if you had a job that was going to take 6 hours. Okay, so let's talk about special cases. It says try this next one to see what special cases look like. So let's do that. If you want to distribute 2 to both terms here, we get 6x minus 8 equals 6x plus 10. Hopefully at this point you see something a little weird about this, but we'll continue. I want to get the variables on the same side, so I'm going to subtract 6x from both sides. And so when I do that, you should see that we have negative 8 equals 10. Okay, what do you notice? The variables cancel out. They're gone. They disappear. Okay, we say that this equation has no solution, since the remaining numbers are not equal, or not the same. We've got no variables. It just says negative 8 equals 10. When does negative 8 equal 10? The answer is never. Right here, we'd say, okay, there's no solution. That's when no solution happens. Okay? Let's look at this next example. Okay, we have x plus 3 times x minus 2 equals 4x minus 6. So I'm going to distribute this 3 here. 3x minus 6 plus x equals 4x minus 6. I notice on this side that I have like terms, so I'm going to put those together. I get 4x minus 6 equals 4x minus 6. Okay, first thing, this line really should stand out to you, because it's the same thing on both sides, but just follow our pattern until we get to what we're trying to see. If I subtract 4x from both sides, I'm left with negative 6 equals negative 6. Again, we should notice that the variables cancel out. We say this equation has infinitely many solutions. Okay, some people can abbreviate it with many, okay, or IMS. Okay, since the numbers remaining are equal. So notice with these two special cases, the one special case happens when the variables cancel out and the numbers are not equal. That's no solutions. The other, infinitely many solutions, happens when the variables cancel out and the numbers do equal each other. Alright, so this practice down here says circle the equations that have no solutions and underline the equations that have infinitely many solutions. So infinitely many solutions basically says the two sides of the equation are the same. Okay, and so let's look at where the two sides of the equations are basically the same. Okay, so here we have 7x minus 1 and 7x plus 1. Are the two sides of the equation basically the same? No. 10x plus 7, 3x plus 7. Two sides the same? No. Okay. Actually, let's just go through and solve. We can talk about the shortcut later. So, here I'm going to try to get the variables to be on the same side. I'll subtract 7x. I get negative 1 equals 1. This is no solution. Negative 1 does not equal 1. So I circle this equation. Okay. For b, I have 10x plus 7 equals 3x plus 7. So I'm going to get the variables to the same side. I'll subtract 3x from both sides. And so when I do that, I get 7x plus 7 equals 7. Then I'll subtract 7 from both sides, and I get 7x equals 0. Okay, 7x equals 0. I'll divide by 7. I should find that x equals 0. Is that a special case? No. X equals 0. Okay, C, I will cross multiply, and when I do, I get, just for space, I'm going to kind of write this up here. Okay, when I do, I get 4x minus 6 equals 4x minus 24. Subtract 4x from both sides. And I'll get negative 6 equals negative 24. This is no solution. It asks me to circle no solutions. And then on the number D, I have 5x plus 4 equals 4x plus 4 plus x. Combine my like terms, I have 5x plus 4 on the left. I have 5x plus 4 on the right. So look, these two sides of the equation are the same. I'm just going to underline this equation. Okay. Why is B not a special case? Because x equals a number. X equals 0. And that's fine. It's not a special case. It would be a special case if the variables cancel out. Okay, the variables don't cancel out. Alright, so there you have it. Solving equations with variables on both sides. Make sure you complete the problems I left for you. And I'll see you tomorrow.